Hi friends, in this video we are going to discuss about voltage regulation. Let's see here, generally what is the definition of voltage regulation? Can you anyone tell me? Very good. Voltage regulation nothing but the change in voltage from no load to full load with respect to full load voltage. The change in voltage from where to where? This is the change in voltage from no load to full load, and with respect to full load voltage is called voltage regulation. Nothing but voltage regulation is equals to the voltage at no load minus voltage at full load upon voltage at full load. Nothing but no load voltage is E, full load voltage is V, and the full load voltage is V. Voltage regulation is equals to E minus V by V is the voltage regulation. But generally we know that E is equals to V plus IAZS. From this, E minus V is equals to IAZS. So from this, voltage regulation is equals to IAZS upon V, or simply per unit ZS. This is the voltage regulation of synchronous machine. What is the voltage regulation of synchronous machine is that IAZS by V. So simply E minus V by V is the voltage regulation for DC machine, synchronous machine, power system, and wherever you. But in transformer, this is with respect to E. Remember this point. Is it okay? Yes or no? Right. Next one. See here, I am simplifying this one. Voltage regulation is equals to IA upon V of ZS. ZS nothing but RA plus JXS. Yes or no? So now tell me, voltage regulation is equals to IA RA upon V plus J into IA XS upon V. We can write like this. So this is, we can written as A plus JB can be written as A cos theta plus or minus B sin theta. A plus JB can be written as A cos theta, nothing but IA RA upon V of cos pi plus or minus IA XS upon V of sin phi. This is the voltage regulation formula. From this, the voltage regulation is equals to, this can be written as per unit R of cos pi plus or minus per unit X of sin phi. This is our final voltage regulation. Or this is also written as percentage R cos pi plus or minus percentage X sin phi. This is also the voltage regulation formula, which is very important. So see, this is about the voltage regulation formula, where the plus is the lagging load and minus for the leading load, and at unity power factor cos pi is exactly equals to 1, sin phi exactly equals to 0. Then what is the voltage regulation at unity power factor? Per unit R or percentage R. This is the voltage regulation of synchronous machine. Of course, these equations are same for transformer also, just here E will comes here. Everything is same other than that. This is what voltage regulation formula. Right? Clear? Are you clear? But they will ask you question on voltage regulation. Then first you have to find this EMF, because voltage regulation is equals to E minus V upon V. So in voltage regulation for problems, you have to know the EMF value. You know this EMF value, V cos pi plus IA RA whole square plus or minus V sin phi plus V sin phi plus or minus IAXS whole square. This is our E value. You have to find E, then you have to find voltage regulation. Remember this. Are you okay? For example, if they given pure capacitive load, if they given pure capacitive load, nothing but this X value is pure capacitive load. This is XS and RA, of course. In pure capacitive load, cos pi value 0, sin phi value 1. Like that they may ask you question. So if pure capacitive, nothing but this E is equals to cos pi 0 and sin phi 1, you have to substitute like that, because pure capacitive, nothing but 0 power factor leading, cos phi 0 sin phi 1. Like that you have to calculate EMF value, then after you have to find out the voltage regulation. If for example they given that RA is equals to 0, we have only excess, then you have to make it 0. And if we again pure capacitive load, then here RA 0, capacitive load, that's why this is totally 0. So what is EMF is equals to square root of V plus or minus capacitive load, sir. It is minus IAXS whole square. These two gets cancelled. So E is equal to V minus IAXS for motor, if V plus IAXS for generator. Like that, you have to calculate the EMF value, then after you have to calculate the voltage regulations. Okay, here some small clarity. Here, this is square root of V minus actually, so IA at an angle 90 degrees. Why? Because of pure capacitive load and excess at an angle 90 degrees, because RA 0, 180, sorry, 90, 180, nothing but simply minus, so it goes plus. Like that. I will give you in problem how we have to calculate this. Are you getting or not? What I am doing here, for this, they given the data RA, armature resistance negligible, we have only excess and pure capacitive load. Pure capacitive load, nothing but the power factor angle is 90 degrees. When RA 0, theta is equals to tan inverse of XS by RA, something by 0, infinite, nothing but theta is the 90 degrees. So we have to calculate EMF. E is equals to square root of, when power factor angle 90, this 0, when RA, this is also 0, so we have only this term, V, this is capacitive load, that's why minus, and IA at an angle 90 degrees, and XS at an angle 90 degrees. 90 plus 90, 180, 180 is nothing but minus 1 and minus goes plus. So what is answer? This is square Square root gets cancelled. So EMF E is equals to V plus IAXS will come. Like that we can calculate easily. They must ask you question based on this data only. In any competitive exam, they are asking question on this only. Regularly they are asking this question. Okay? Are you okay or not? Understood? Right. So this is about the voltage regulation. Now, I want conditions for voltage regulation. What is that? Conditions for zero voltage regulation and condition for maximum voltage regulation. We have to calculate that. So let's see here. I'm going to calculate the conditions. What are the conditions to get the maximum voltage regulation as well as to get the minimum voltage regulation? They may ask you question in our competitive examination. Let's see here how we can calculate those conditions. First one, condition for zero voltage regulation. Condition for zero voltage regulation. Actually, voltage regulation formula is equals to E minus V upon V, and IA RA cos pi, nothing but per unit R cos pi, per unit R cos pi plus or minus per unit X sin phi. This is voltage regulation formula. When we can get zero? When we can get zero? For positive or negative? Exactly, for negative only we can get zero, otherwise it is not possible. So negative nothing but the zero voltage regulation will take place in what load? In leading load or lagging load? Exactly in leading load only. There is no possibility for lagging load because both terms are added. Even though in unity power factor also it is not possible, because in unity power factor the voltage regulation is just per unit R. So the zero voltage regulation occurs only in leading load. This is very important, repeated question. Right? Next one. Here I want condition for zero voltage regulation. That's why we have to make it zero. Voltage regulation is equals to zero, or simply E minus V upon V is equals to zero. Simply E minus V is equals to zero. What is E's are here? We have to substitute E. E is equals to square root of V cos pi plus IA RA whole square plus V sin phi minus IAXS whole square because of capacitive leading load. We have to substitute here and make it calculate. If you calculate this one, after solving all the equations, you will get the answer cos of theta plus phi is equals to, very important, listen carefully here, cos of theta plus phi is equals to minus IAZS upon 2V. This is the exact condition for zero voltage regulation. Exact condition for zero voltage regulation. Very important. They already asked one gate question on this formula. Be careful. If RA is 0, then you have to take excess here. If armature resistance negligible, you have to take excess here. So this is cos of theta plus phi is equals to. This is exact condition. But for approximation, what is my approximation here? Generally, the IAZS is very less than 2 times of voltage. IAZS is very less than 2 times of voltage. If this is done, then the equation cos of theta plus phi is equals to 0 upon 2e, because IAZ is negligible. So finally this total value 0. So what is the approximate condition? Cos of theta plus phi is equals to cos 90 degrees. Yes or no? 0, nothing but 90 degrees. Now tell me, what is the approximate condition for zero voltage regulation? The approximate condition for zero voltage regulation is the impedance angle, power factor angle should be equals to 90 degrees. Impedance angle and power factor angle should be equals to 90 degrees. This is the approximate condition for zero voltage regulation. Is it okay? Right? Right. So here this is the exact condition and this is the approximate condition, and the zero voltage regulation occurs in leading load. These are the things you have to remember in this video. The condition for zero voltage regulation. Next, what is next? The condition for maximum voltage regulation. In generally, the voltage regulation formula is this one, plus or minus. Voltage regulation is equals to E minus V upon V. That is equals to per unit RA cos phi plus or minus per unit XS sin phi. Now tell me, at what condition we can get the maximum voltage regulation, for positive or negative? Exactly, for positive we can get the maximum voltage regulation. So now tell me, the maximum voltage regulation always occurs at what load? In lagging load. Maximum voltage regulation occurs in lagging load only. Right? Next one. Here, to get the maximum voltage regulation, differentiate the voltage regulation with respect to variable and equals to 0. Here, what is E? E is equals to square root of V cos phi plus IA RA whole square plus V sin phi plus IA XS whole square. We have to substitute here and differentiate with respect to variable, that is either IA or phi. At this condition, if you solve all these things, you can get the exact value. Sine of theta minus phi is equals to 0. This is the condition for maximum voltage regulation. This is exact condition. And what is approximate condition here? Approximate condition here, same. Sine of theta minus phi is equals to sine 0, where minus is there. If it is plus, you have to take 180 degrees here, but here minus, then you have to take 0, the appropriate value. You have to take appropriate value. So now tell me, what is the answer? Theta minus phi is equals to 0. So theta is equals to phi is the condition for maximum voltage regulation. Yes, maximum voltage regulation condition and zero voltage regulation condition, both are very important. These conditions are same for synchronous machine and transformer. Very secret. Okay, these two conditions are same for synchronous machine and transformer. Is it okay? Listening or not? Right? So this is the condition for maximum voltage regulation. Up to now, what are the key points you learned in this video? One, the zero voltage regulation occurs in leading load, and the condition is theta plus phi is equals to 90 degrees. Maximum voltage regulation occurs in lagging load, and the condition is theta is equals to phi. This is the key points you learned in this video, right? So I completed the condition for minimum or zero voltage regulation and maximum voltage regulation. Now let's draw a graph for this voltage regulation. Let's draw a small graph for easy understanding. For easy understanding, let's draw a graph. See, this is the flat this is lagging load, and this is for leading load, and here at this point unity power factor. Here power factor is 1, here power factor is 0.9 lagging, here the power factor is 0.8 lagging, for example here 0.6 lagging, for example here 0.2 lagging, for example here 0.1 lagging, and here 0 lagging. As usually, here unity, here 0.95, here 0.9 leading, here 0.8 leading, here 0.6 leading, and so on. This is unity. This is positive voltage regulation, and this is negative voltage regulation. Positive voltage regulation, above the x-axis positive voltage regulation, below the x-axis negative voltage regulation, on the x-axis zero voltage regulation. So at what condition we can get the maximum voltage regulation? I said you in lagging. Yes or no? I said you in lagging. Actually, at maximum voltage regulation, what is the power factor? In generally, the maximum voltage regulation condition, theta is equals to phi, right? Theta is equals to phi. Generally, pure resistive load is not possible. Pure resistive load is not possible. Pure inductive load also may not possible. So pure inductive load not possible. That's why lagging load nothing but R plus L load. In R plus L load, we can get the maximum voltage regulation. But here, the L value is maximum, resistive value is minimum. Then only in lagging load, we can get the maximum voltage regulation. That is mostly the power factor angle is nearly 80 degrees plus. At that condition only we can get the maximum voltage regulation. At this condition, generally the maximum voltage regulation occurs in between 0.1 to 0.2 lagging, because 80 degrees to 85 degrees range. So at 0.1 to 0.2 lagging, we can get the maximum voltage regulation. Right? Then next, at unity power factor, voltage regulation is equals to simply per unit R. Tell me, per unit R is the positive or negative or zero? Zero is impossible. Zero resistance, is it possible? No. Negative resistance, is it possible? No. So the per unit resistance is nothing but it must and should positive only. Negative and zeros are not possible. But in lagging load, voltage regulation is per unit R cos pi plus per unit X sin phi. Tell me from lagging to unity power factor, voltage regulation reduces or increases? Here it is maximum. If here it is maximum, when comes to here, nothing but from this equation to this equation, the voltage regulation reduces ultimately. So from lagging to unity power factor, voltage regulation reduces ultimately. Okay, so reduces. Here the voltage regulation is per unit resistance. here the voltage regulation reduces. This is for lagging. But in whole lagging and unity power factor, the voltage regulation is positive only. There is no zero, no negative. But when comes to leading, voltage regulation is equals to per unit R cos pi minus per unit X sin phi. This is the voltage regulation in leading load. Nothing but in some case it may positive, in some case it may zero, in some case it may negative. See here, if this is the greater than this one, 10 minus 5 is the 5 positive. If this is greater than this one, then 10 minus 15 negative. If both are same, 10 minus 10 0. So here the voltage regulation curve goes like this. Here first positive, then next in between 0.95 to 0.9 it is 0. It is 0, positive 0. After 0.9 value it goes in negative. It goes in negative. So in lagging the voltage regulation is positive. At unity power factor the voltage regulation is positive. In leading somewhat positive, then after 0, positive to 0, then after enters into the negative. So this is the voltage regulation curve. Voltage regulation curve. At what condition we can get the 0? Generally here the 0 voltage regulation condition is theta plus phi is equals to 90 degrees. Here I said you already, for example, phi is the 80 degrees, then theta is the 10 degrees. Sorry, if theta is the 80 degrees, then phi is the 10 degrees, which is equals to 90. Nothing but nearly at 10 degrees. Nearly at 10 degrees, cos 10. Did you get it? Cos 0, 1. Cos 10 around 0.9, 0.95 in the range. So it goes to 0. It goes to 0. Voltage regulation 0 at nearly cos 10. And nothing but 0.95 to 0.9 leading. We can get the 0 voltage regulation. So this is simply about the voltage regulation. Here in leading, when the power factor value decreases from unity to leading, then voltage regulation increases. Are you getting or not? From unity power factor to leading, from unity power factor to leading, voltage regulation increases. From lagging to unity power factor, voltage regulation decreases. This is the voltage regulation curve. So finally, what is the conclusion? Tell me, in lagging load, what is voltage regulation? Voltage regulation is positive. At unity power factor, what is voltage regulation? Voltage regulation is positive. In leading load, what is voltage regulation? Voltage regulation sometimes positive, then it may 0, then it may negative also. Positive, 0, negative. This is the voltage regulation. They will ask you question in reverse. Where we can get the negative voltage regulation? Where we can get the negative voltage regulation? Only in leading we can get the negative voltage regulation. Where we can get the 0 voltage regulation? Zero regulation we can get only at leading load. Where we can get the positive voltage regulation? Positive voltage regulation we can get in lagging, at unity power factor, even in leading also. So all of the above, positive, but negative and 0 only in leading. This is the conclusion of voltage regulation. Are you getting or not? Is it okay? Right. Now I will ask you one simple question. Let's see. I will redraw this diagram. I will draw this diagram again, and I will ask you some questions. Give me the answer fast. Give me the answer quickly. So see that graph. See that graph. This is positive voltage regulation and this is negative voltage regulation. This is lagging and this is leading. They won't ask you, they won't give you this diagram in the examination. This is for your reference purpose. So generally the voltage regulation curve is like this. This is, we know, unity power factor. For example, they given this is 0.8. For example, this is 0.6. And for example, this is 0.8. And for example, this is 0.6. Now they will ask you question. Voltage regulation at 0.8 lagging. Voltage regulation at 0.8 lagging is 20%. Then voltage regulation at 0.8 leading. Voltage regulation at 0.8 leading. So options they given: option A minus 20%, option B 0%, option C 12%, option D minus 9%. Tell me which of the following is correct answer. They given like this. There is no data. Just this is the question, that's it. So tell me the answer. See here, voltage regulation at 0.8 lagging. At this condition, for example, this is diagram drawn by us, not by the examiner. So we are assuming that this is 20%. Then what is the voltage regulation at 0.8 leading? Nothing but what is this voltage regulation? Is it minus 20? This is 20. If it is minus 20, it should be this much. So this is wrong answer, sir. Is it 0 at 0.8? Is it 0? No. 0 occurs at 0.952, 0.9 leading. So this is also wrong answer. Is it plus? In leading 0.8, is it positive? No, this is negative. So what is the value? The value is negative, but is the greater than lagging or less than lagging? It should be a less than lagging value. So less than lagging value. Therefore, voltage regulation in leading is less than voltage regulation in lagging. Voltage regulation in leading is less than voltage regulation in lagging. That too, this is negative and this is positive. Always voltage regulation in leading is less than voltage regulation in lagging, that too in negative. But the efficiency in leading is exactly equals to efficiency in lagging for same power factor. For same power factor like this, the efficiency is exactly same. But the voltage regulation is not same. In lagging, positive. In leading, it may be negative. Mostly it is negative. Most of the curve is in negative. That too, less than the lagging value. You should remember this. Okay. Right. Next question. Next question. Same question. What is voltage regulation at unity power factor? What is voltage regulation at unity power factor? Option A, 25%. Option B, minus 3%. Option C, 13%. Option D, minus 28%. Now tell me, first of all, excuse me. First of all, the given voltage regulation at lagging is 20%. Then voltage regulation at unity power factor. At unity power factor, voltage regulation positive, negative or 0? It must and should be positive. So these two are the wrong answers. Next one. Is the voltage regulation from lagging to unity power factor increases or decreases? Voltage regulation from lagging to unity power factor, from lagging to unity power factor decreases. So it should be less than less than lagging. So less than 20 is the 13%. Nothing but they given this is the at 0.8 lagging 25. What is at unity power factor? What is this much? Is this is 25? No. 20, they given 20, right? At lagging 20%. And what is this is? Is this is 25 greater than 20 or less than 20? Less than 20. What is less than 20? Minus 3 is there, 13 is there. So minus 3 is the wrong because at voltage regulation at unity power factor is positive. So the answer is 13%. Like that you have to make the answer. Getting or not? Okay. Right. Next one. Next question. This is the way of questioning they will ask you. And next question. In synchronous machine, the voltage regulation depends on. In synchronous machine, the voltage regulation depends on. Option A, type of load. Type of load. Option B, magnitude of load. Magnitude of load. Option C, speed. Option D, correct answer. What is correct answer? Option D, sir. What is option D? Yeah, exactly. The voltage regulation depends on type of load and magnitude of load, but independent of speed. Independent of speed, same as a armature reaction. But in DC machine, the voltage regulation depends on. But in DC machine, the voltage regulation depends on magnitude of load and speed. There is no type of load. DC nothing but always only one load, pure resistive. There is no questioning of lagging and leading. So in DC machine, the voltage regulation and armature reaction depends on type of load and speed. But in synchronous machine, the voltage regulation and armature reaction depends on type of load and magnitude of load. This is next question. And next to small point. In generally, the synchronous machines or alternators or synchronous machines, manufacturing it, designing it, voltage regulation of around 30 to 35%. Voltage regulation of 30 to 35% in generally. But in modern alternators, in new alternators, the voltage regulation is designed up to 60 to 70%. 60 to 70%. Voltage regulation nothing but IAZS upon V. If voltage regulation maximum, nothing but the synchronous impedance also maximum. Sir, why the modern alternators are designed for high voltage regulation? High voltage regulation, nothing but high impedance. High impedance is very advantageous to avoid the short circuit currents. To avoid the short circuit currents. So modern alternators are designed for high voltage regulation in order to avoid the short circuit currents. In order to avoid the short circuit currents, we are going to maintain higher voltage regulations. Right? This is very simple question. This is also completed. Final question, very simple question. You have to give me the answer. So, option A, 3%. Option B, minus 20%. Option C, 35%. Option D, minus 42%. Now tell me, which of the following is a best voltage regulation, better voltage regulation, required voltage regulation? Which of the following is a best voltage regulation? Tell me. Tell me. 35% or minus 42%? Yeah, the minimum voltage regulation is the best voltage regulation. The voltage regulation should be minimum. So which of the following is the best voltage regulation? 3% is the best voltage regulation or good voltage regulation, better voltage regulation. Which of the following is the poor voltage regulation? Tell me, which of the following is the poor voltage regulation? Yeah, which of the following is the poor voltage regulation? Minus 42. Even though that is minus or positive, no worry. This is the considerable. 35 or 42. Of course, negative represents leading, positive represents lagging. But 35, 42. So 42 is the biggest. That's why this is the poor voltage regulation or worst voltage regulation. Worst voltage regulation. This is the voltage regulation concept which is very important. They must ask you question in voltage regulation. Is it okay? Understood? Thank you.